is equal to 2, 3. Then 3a is equal to 6, 9. So what you did is you changed the scale, the magnitude, that's what Dr. Thomas said in the first place, is you stretch the line a multiple of 3 times. Or how about this? In the same direction as the original line, 2, 3, you did this. Look up here. Here is 2, 3. So what I did is I put 3 of those vectors together. So I took this one and I put it here, and then I put it there. Yeah.
I want to give an example. Let's say you tell somebody you're 300 miles from New Orleans. That's a distance. But you could be in Shreveport, you could be in the Gulf of Mexico.
Yeah.
Displacement tells you you're 300 miles from New Orleans, exactly where your endpoint is.
Yeah. Very good. Okay. Let's see. Next is unit vectors. A unit vector is a vector of what? How do you describe a unit vector?
Of one.
Of length 1. Agreed? So, back to my A. Only this time it's going to be a 3-dimensional. Could have been single dimensional, but I just picked 3-dimensional. Okay? And I want to find a unit vector in the same direction as A. Okay? So what I want to do, let's see, I think I'm going to find this. What's that? The length or the magnitude, and I think that's equal to the square root of 4 plus 9 plus 1. What do you think? Isn't that using the three-dimensional distance formula? Everybody agree? And because I didn't specify a beginning point, in the beginning point the tip assessed finger as opposed to over here. So isn't that the square root of 14? Right? So I think that the vector u equal to the original vector A divided by the length of A equal to is the unit vector in the same direction as A. Doesn't it just make sense if you want a vector if you're given a vector and you want a unit vector in the same direction, wouldn't you divide that given vector by its length, and wouldn't that make it be 1? And if you don't believe me, find the magnitude of that vector. And that is, you would do 2 squared over, you would do wouldn't you get 4 over 14 plus 9 over 14 plus 1 over 14? And isn't that the square root of 14 over 14, which is the square root of 1, which is, and isn't that what we were looking for? Everybody agree? So if I ask you for a unit vector, you take the given vector, find its magnitude, divide it by the, divide every component by the magnitude, and that gives you a unit vector. And look, if, where's my problem? See the inch marks? Here's a unit vector out in space. I mean, here's a vector out in space. And imagine wherever the 36 is, that's a 39, that's a meter stick. But imagine wherever this end is an arrow, okay? I need to make me an arrow to flip on there. But anyhow, and it looks like this. What we have found is, we have found that vector between my 2 fingers. Same direction, but length 1. 1 what? 1 whatever your unit of measurement is. Okay? All right? Now, I tell you again, distance is the distance formula, the magnitude of the vector. Direction is specified by a unit vector. Unit vectors typically are U and V, I, J, and K are special unit vectors. So, I guess it's time to tell you about I, J, and K. Whoops. What's the length of that vector?
1.
1. What is that vector parallel to?
X.
Parallel to the x-axis, right? So this is used to describe the x component. Agreed? J, I'll bet you can guess. That's a unit vector that is used to describe a y component. Okay? And K is used to describe a Z component. So you tell me, what is 2I plus 3J plus K? What's that equal to? Well, I think 2I is the vector. Do you think that? And then do you think that 3J is the vector? And do you think that K by itself is? And how do you add vectors? How do you add vectors? How do you add vectors? Come on.
One vector at a time.
Yeah, how about we say one component at a time? Don't you add all the first components and all the second components and all the third components? Isn't that right? So isn't this 2 plus 0 plus 0, which is 2, and then 0 plus 3 plus 0 is 3, and 0 plus 0 plus 1 is. And I'm telling you that that's our vector A, and that this is another way of writing the vector A. All I can tell you is, for right now, forget about imaginary numbers. That I is no longer the square root of -1. Forget about that. Okay? Questions? So I can define a vector one of two ways. I can define it like this, by isn't this its endpoint? Isn't this its endpoint? And I tell you that it's not the point, but all points in between this point and the origin. And the way I tell you that is these symbols, huh? But then I could also define it as this, where you know what the vectors I, J, and K are. Okay? So, also, a little bit on notation. Typically, a capital letter A is a point. A letter like that, whether it is capital or lowercase or Greek or anything else, that says a vector. Okay? And then smaller letters, those are either a number or a vector, depending on the context. So what you're going to see me do from now on is I'm going to try to call vectors lowercase with that over it. But you'll know anyhow, won't you? You'll know anyhow. If there's any doubt or ambiguity, I'll put it. But look for a lowercase to mean a vector and uppercase to mean a point. Okay? Ed and Beth, what have I left out?
Dot product, you coming in on that?
Do what?
You got dot product and cross product.
Yeah, I just haven't got there yet.
Do they know the determinants yet?
No, I hadn't even told them about it yet.
Okay.
And I've got that, we have done 12.1 and 12.2. You might go ahead and start on that homework as soon as you get this test out of your way. Okay? And on Friday, I'm going to do 12-3, 12-4. And, we got another test next week. Test 4 will be next week. When is it? Test 4, no, it's not next week. I got all next week to cover chapters 12 and a little bit of 13. And, the test starts on Monday, May the 5th. The final starts on Thursday, May the 8th.
Is that one day? Take that final?
No, as usual, 2 days. On Thursday, May the 8th, and you'll have Thursday, May the 8th, and Friday, May the 9th in the morning.
Here?
Yeah,
Okay.
that Friday in the morning. Okay. Questions? All right. Nobody in here graduating? This isn't a graduating class, is it? If you're in Cal 3, the odds are you need Cal 4, right? You can graduate with our associate without differential equations. You know you can do that. Most people, and the 3 schools have told us they like the idea of you having all your math when you go there, but you don't have to. You get the associate's degree, and you can go to any of the 3 schools with that associate's degree and just take DE there. We've got our first going to Big LSU in the fall. We've got now I think 3 going to ULL in the fall, and then we got a dozen or so going to Tech in the fall.
Is DE not? It's not this book, is it?
No.
The Calculus 4 is this book.
Yes. 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 Okay. I'll see you Friday.